Dear viewers of Akshi.com, by Vetri from Pondicherry. Good evening. In my previous lectures, under general principles and process of isolation of elements, I have discussed different steps involved. Number 1, grinding. Number 2, concentration or tracing of force. Number 3, conversion to more suitable form. Number 4, extraction of impure metals. And number 5, purification of metals. In each and every cases, every steps, I have explained with a suitable example the process involved. But I have not taken any specific example. In my last lecture, I have taken, that is as per CBSE syllabus, I have selected 4 metals and I am now discussing. The last class I have discussed copper. Today, I am going to continue with zinc, extraction of zinc metal from zinc blend. Okay, let me continue. So, zinc, it is existing in the form of different ores. The most important sulfide ore, zinc sulfide, the name is zinc blend. The carbonate, another one is zinc carbonate, carbonate ore, the name is calamine, is that an CO3. And another oxide ore, name is zincite, is that an O. So, from these ores, sulfide ore, carbonate ore and oxide ore, we can extract zinc. So, in this, I am going to use zinc blend. I will explain how zinc can be extracted from this zinc blend. Okay. As I have already pointed out, there are 5 steps involved. So, I am going to apply these 5 steps again from the zinc sulfide, that is zinc blend. I am going to extract zinc as usual. Number 1, grinding. Number 2, concentration. Number 3, conversion to more suitable form, that is either by calcination or by roasting. Extraction of zinc from the zinc sulfide, that is impure. Then purification of zinc metal. So, I will explain one by one the steps involved here. First one is grinding. So, zinc is mainly extracted from the ore zinc blend. That is the first information. Zinc blend, in the form of zinc blend, it is available. So, what we have, so naturally occurring zinc blend is finely powdered. We have to make it powder by grinding in ball mill. This is the simple first step. So, zinc blend is naturally occurring. So, which is we have to collect and make it powder by grinding in mill, that is the ball mills. Step 1. Step 2, concentration. Under the concentration, we know the number of steps are involved. What are the? Hand picking, gravity separation, froth flotation process, magnetic separation, electrostatic separation, chemical separation. So, a number of methods are available here. So, in this case, zinc it is a sulfide ore. Here, in the case of zinc blend, the finely powdered ore is concentrated by froth flotation process. So, I am selecting specifically froth flotation process for zinc sulfide because it is a sulfide ore. So, froth flotation process is applicable for any sulfide ore. Okay. Here, the ore is wetted by oil and the gangue by water. This is the basic principle involved there. So, the sulfide ore floating at the top can be removed and collected. This is the interesting information. The sulfide ore floating at the top can be removed and collected, so that we can concentrate, that is zinc blend ore. Then step 3, conversion of zinc blend ore to more suitable form of ore, that is oxide ore by roasting. So, zinc sulfide should be converted into oxide ore either by roasting or even calcination. So, here the concentrated ore is roasted at about 1200 Kelvin, very high temperature in excess of air. This is called roasting. So, what will happen now when we are heating with oxygen, that is the zinc sulfide is converted into zinc oxide. So, sometimes along with the zinc oxide, some zinc sulfate may be also formed. So, any zinc sulfate that is formed by its oxidation changes to zinc oxide again on roasting. So, directly zinc oxide is okay, no problem. but even zinc sulfate little is formed that can be on oxidation, on heating with the air, again it is converted into corresponding zinc oxide. So let me explain the reaction. So 2 moles of zinc sulfide reacts with the 3 moles of O2 to produce 2 moles of zinc oxide and 2 moles of sulfur dioxide. So the zinc sulfide is getting converted into zinc oxide by roasting with oxygen, right? Then what will happen now? Again this zinc sulfide, when you treat it with oxygen, I have already pointed out, maybe a small amount may be converted into zinc sulfate. We cannot control, it may go to zinc sulfate. So even that zinc sulfate that is formed on calcination, when we are heating, so it is converted into again zinc oxide, sulfur dioxide and oxygen. So final product is only zinc oxide, sulfur dioxide and oxygen. So this is the interesting information that is taking place under the step 3. Okay. Step 4, extraction of impure metal, extraction of zinc. Now we are taking here. The roasted ore is then mixed with the coke, that is coke, and taken in fire clay retard, which consists of bottle shaped fire clay tubes closed at one end and fitted with earth, that is earthenware condensers at their mouth. This is the interesting information. So roasted ore is then mixed with the coke, carbon, right? So what will happen now when we are heating? These have been heated strongly in a reverberatory furnace. I have already explained what is a reverberatory furnace, how we are using in a general principle I have discussed. So when we are heating this in a reverberatory furnace, what is happening? Let me explain now. So here zinc oxide is reduced to zinc by carbon, and the carbon monoxide formed here burns at the mouth of the condenser with the color of blue flame. This is the interesting information. So impure zinc thus obtained is called zinc spelter. This is an interesting information. So when we are heating zinc oxide with the carbon, that is zinc oxide is getting converted into zinc and carbon monoxide is formed, so which is burning with a blue flame. So the impure metal thus we are obtaining, we are calling it as zinc spelter. This is the reaction. ZnO plus carbon gives Zn plus CO. So this is the interesting information taking place in the step 4. The next one, step 5, final. So from impure zinc metal, we are going to prepare pure zinc metal. What we have to do? So that is purification. Impure zinc containing lead, iron, cadmium and arsenic can be purified either by fractional distillation or by electrolytic method. There are 2 methods we can follow to purify zinc. In this case, in step 5. So let me explain one by one. Under the fractional distillation, pure zinc can be obtained from impure zinc by distillation at that is 1170 Kelvin to 1270 Kelvin. So between this high temperature, now so distillation we are doing. So when we are heating at this high temperature, what will happen? Arsenic present as an impurity volatiles away first. Arsenic volatiles away first. Then zinc metal with the traces of cadmium leaving, again coming out as a volatile. So leaving behind iron and lead which are non-volatile. So first arsenic goes away, then zinc along with the traces of cadmium also leaving away, leaving iron and lead which is non-volatile. So what will happen now? 100% pure zinc can be obtained by repeating the same process. By repeated distillation, we can get 100% pure zinc can be obtained. This is the interesting information regarding extraction of zinc. Okay, here that is the first method, distillation. The second method is electrolytic method. Also we can purify zinc. So let me explain now what is happening in the electrolytic method. Here impure zinc acts as an anode, very interesting information, and pure zinc plates act as a cathode in an electrolytic cell. And with the zinc sulfate solution containing little sulfuric acid act as an electrolyte. Kindly follow. This is not a new, I have already explained many times. A cell, that is the 2 electrodes. The one electrode is impure zinc is acting as a cathode and pure zinc is acting as an anode, and zinc sulfate containing traces of sulfuric acid is acting as an electrolyte. So on passing electric current, what will happen? Pure zinc from the electrolyte, from the solution, gets deposited on the cathode. Gets deposited on the cathode. What will happen now? An equal amount of zinc from the impure plate goes into solution from the anode. So from the anode, the metal, impure metal dissolves equivalent amount, will go into solution. So from the solution is getting deposited, and equivalent amount again from the impure is going inside. So this is going on, taking place. So we are getting more and more pure metal zinc. We are getting that. This is the way we have to purify, to extract zinc from zinc brine. Okay, next let me go for, I will explain how iron can be extracted from its ore, specifically here limonite. Okay, let me do this. So iron, as usual, what are the common important ores of iron? So here I have listed 4. Hematite, formula Fe2O3, I can extract iron. Another is a limonite, formula Fe2O3.3H2O, again I can extract iron. Magnite, another ore, oxide ore, again Fe3O4, again I can extract. And siderite is a carbonate ore, FeCO3, again I can extract iron. This is a common ore available there. So here I am taking specifically limonite. I am going to explain how iron can be extracted from limonite systematically. Okay. As usual, there are 5 steps involved. Number 1, grinding. Number 2, concentration. Number 3, conversion to more suitable form of ore. Number 4, extraction of iron. And number 5, purification. These are the steps involved there. Okay, next one. First one, grinding. Iron is mainly extracted from the ore limonite. I have already pointed. Limonite nothing but Fe2O3.3H2O. So naturally occurring limonite is finely powdered by grinding and balming. This is the routine procedure. So it may be first step, we have to make it powder form. Second, concentration. I have already pointed out a number of methods are available. So it's an oxide ore. We have to follow suitable method for whatever method we are following for oxide. So in the case of limonite, the finely powdered ore is concentrated by following any suitable method applied for oxide ore. So we can use. This is called concentration. And step 3, conversion to more suitable form of ore, either by calcination or by roasting. That is the conversion. So here, therefore, here the ore after washing is calcinated or roasted in electric furnace. So what will happen now? When we are heating Fe2O3.3H2O converted into Fe2O3, water is getting eliminated. When the mass of water is getting eliminated, automatically iron content, the percentage of iron content increases. That's why it is now we can say more suitable form. Without water we are having. So it is the step called conversion to more suitable form. So we are taking the suitable form is Fe2O3. Okay, next one. Extraction of iron, impure iron. Extraction of iron, step 4. So what is happening here? In this case, the roasted ore is mixed with coke and heated in blast furnace for smelting. That we have followed already in the step 3. We are heating with carbon and heated in a blast furnace for melting. So what will happen now? When we are heating iron oxide, Fe2O3 is reduced to iron by carbon monoxide in stages. So when we are heating with coke carbon monoxide form, that carbon monoxide reacts with Fe2O3 in different steps and finally converted into iron. So let me explain now. So first step, 3 moles of Fe2O3 reacts with CO 2 moles to produce 2 moles of Fe3O4 and carbon dioxide. So first conversion is Fe3O4. So then Fe3O4 again reacts with the CO to produce 3 moles of FeO, then carbon dioxide again. Then this FeO again reacts with the carbon monoxide, converted finally iron and carbon dioxide. In all the cases, carbon dioxide is formed. So the Fe2O3 is converted further Fe3O4, second FeO, third finally iron. In 3 different, each and every case, carbon monoxide is getting we are using. So it is, and this is reducing. So this is the very, very interesting information that is taking place in the extraction of iron. Now, what will happen now after this? Finally, at the bottom of the furnace, when we are heating with carbon monoxide, the molten iron sinks down, while above this floats the fusible slag. Slag is floating on the iron. So, what of this slag which protects the molten iron from oxidation. So, the oxygen, the iron, further oxidation should not take place. So, this slag protects the molten iron from oxidation. So, the molten iron and slag are collected separately, which is provided at the bottom of the furnace. Slag on the one side and the molten iron on the other side. The iron thus obtained is called pig iron. Kindly follow. Pig iron. The solid pig iron or iron on remelting in a vertical furnace to get cast iron. So, cast iron is a better lesser impurity than big iron. So, cast iron is 2 to 5%. So, big iron still higher impurity will be there. So, next. Another iron is called wrought iron. Kindly student, there are 3 iron, introducing 3, pig iron, cast iron and wrought iron. So, wrought iron is the purest form of iron and is prepared by heating cast iron containing 2 to 5%. I have already pointed out. 2 to 5% impurity of carbon is present there in a reverberatory furnace lined with iron oxide. Very interesting information. So, wrought iron, which is the purest iron, we are getting from cast iron, that is cast iron is containing 2 to 5% of carbon. Right. The carbon present in the cast iron is oxidized by the iron oxide to get wrought iron, which contains only 0.2% of carbon. So, very less impurity. Carbon impurity is very less in the case of wrought iron. So, wrought iron is the purest form. This is the interesting information I want to record here. So, this is the way we have to extract iron in the corresponding from its. Now, let me go for the next one, that is extraction of aluminum from its ores, specifically bauxite and cryolite. So, aluminum exists a number of that is ore form, that is aluminum has a number of ores. So, it exists in the form of corundum, the formula Al2O3, diaspore, formula Al2O3.H2O, bauxite that I am going to use in this, formula Al2O3.2H2O again Al. So, cryolite Na3AlF6 and feldspar, it is KAlSi3O8, and alunite or alum stone, formula K2SO4.Al2SO4 thrice 4AlOH thrice again from this. So, I will take specifically here bauxite and cryolite. I will explain how aluminum can be extracted from this ore. Okay. Now, steps involved in extraction, that is the extraction of aluminum. The interesting information as usual: grinding number 1, concentration number 2, conversion to more suitable form number 3, extraction of aluminum, impure aluminum 4, and finally purification. So, by following these 5 steps, I am going to explain how aluminum can be extracted from its ore bauxite. As usual, step 1 here, under this step 1, grinding. Aluminum is mainly extracted from its ore bauxite or cryolite. Bauxite is an oxide ore, cryolite is an again aluminum that is containing the halide. So, naturally occurring bauxite ore is finely powdered by grinding in ball mills. This is the usual steps we are following. First, we have to make it powder in step 1. Under the step 2, concentration, I have a number of methods available. This is an oxide ore, we have to follow any suitable method applied for oxide. So, in the case of bauxite ore, the finely powdered ore is concentrated by following any suitable method applied for oxide ore. We can apply. So, that is, so we can concentrate. After concentration, next one, conversion to more suitable form of ore, that is step 3. So, we have to go for this step 3. This is the interesting information. So, here the concentrated ore is converted more suitably like other oxide ore to more suitable form. That is by calcination or by roasting we have to follow. Then step 4, extraction. So, in this case, specific method we are following, I have given already under the extra number of methods we are. So, one of the methods we are following is here I am going to use electrolysis of fused alumina I have to apply. So what will happen in the metallurgy of aluminum? So aluminum oxide is mixed with Na3AlF6, which lowers melting point of the mix and brings conductivity. This is the interesting information. So aluminum oxide is mixed with Na3AlF6. So why we are mixing Na3AlF6? Which lowers the melting point of the mix and brings conductivity. So now this fused mass, the fused mass is then electrolyzed. We have to pass electric current. What will happen now? Here steel cathode lined with the carbon and the graphite anode are used for electrolysis. This is the interesting information. Right. So this process of electrolysis is widely known as Hall-Héroult process. Hall-Héroult process. This process is called Hall-Héroult process. Okay. What is happening? Here, during electrolysis, aluminum is produced and zinc to the bottom, while oxygen appears at the anode, which are oxidized thereby and have to be replaced from time to time. So when oxygen appears at the anode, which are oxidized thereby and should be removed, replaced from time to time. Okay. As the concentration of alumina falls down, then the resistance of the bath increases and is indicated by the charge control lamp which glows. So after identifying this, so more alumina is added to make for the loss. So whenever this indication in the control lamp glows, so more alumina is added to make for the loss, and we have to proceed for that. So then aluminum metal formed here is tapped from time to time through the tapping hole near the bottom. So near the bottom there is a hole through which the aluminum is we have to tap it out from time to time. So the metal thus obtained is about 99% pure. Kindly follow. 99% pure aluminum we are getting by this method. Right. So the reaction that are taking place are at cathode Al3 plus by accepting 3 electron converted into aluminum. At anode, the carbon solid again combines with 2, that is oxide ion, 2 negative, to produce carbon dioxide, and 4 electrons are liberated. So liberation of electron that is taking place in the anode along with the carbon dioxide. This is taking place. So we are getting this impure ion. The final is purification. So purification of impure aluminum. So purification of purification of aluminum, pure aluminum from impure. So large quantities of aluminum metal are refined today by Hoops process. Hoops process. This process is called Hoops process. What will happen here? In Hoops process, in a carbon lined tank are placed 3 layers. Kindly follow here. In a carbon lined tank are placed 3 layers differing in specific gravity. Very, very interesting information. There are 3 layers which is present in a carbon lined tank. So what will happen now? 3 layers. Impure molten aluminum containing copper and silicon forms bottom layer. So at the bottom layer, impure molten aluminum will be there containing copper and silicon as impurity and serves as the anode. Okay. Then a mixture of fluorides of sodium, barium and aluminum in the fused state and saturated with alumina constitute the middle layer. This is at the middle layer. Right. Pure molten aluminum is at the top layer serving as a cathode. This is the interesting. So 3 layers. Bottom is the anode, central layer, middle layer, and then the top the molten aluminum is at the top layer serving as a cathode. These are 3 layers based on the specific gravity. On passing electric current, aluminum from the middle layer passes into upper layer. From the middle to upper it passes. In order to compensate, at an equivalent amount from the bottom layer passes into the middle layer. So from the bottom, it is in order to compensate, the aluminum go into the middle layer. So by this process, pure aluminum 99.98% of is extracted and tapped from the top. This is the interesting information we are getting. So by this way, I can extract aluminum oxide ore. So this is the interesting information regarding the general principle and process of isolation of element. So I hope I have discussed the 4 important example, specific example, and I have explained specifically. I hope you have enjoyed the lecture.